There it is, Tranquility Base. The Eagle has landed, July 20th, 1969. And right now, at this very moment, that spacecraft is still there, sitting on the moon, waiting, just 240,000 miles away, close enough that light from it reaches your eyes in barely over a second. But here's what nobody tells you. You will never see it. Not with your eyes, not with any telescope you can buy, not even with the most powerful observatory on Earth. The thing that proved we went to the moon is invisible to us forever, separated by something you'd never expect. And I'm going to show you exactly why by the end of this video. Trust me, the reason is going to blow your mind. But first, quick question. Where are you watching this from right now? Drop your country or city in the comments. I'm genuinely curious how far this reaches. Okay, so let's rewind, because to understand why we can't see the most famous landing site in human history, we need to talk about what's actually up there. Between 1969 and 1972, we didn't just visit the moon once, we went 6 times, 6 separate missions, 6 different landing sites, and we left behind a shocking amount of stuff. Every mission abandoned their lunar module descent stage. That's the bottom half of the spacecraft, the part with the landing legs. It's 31 feet across with the gear deployed, about the size of a small house. We left flags, footprints that will last millions of years because there's no wind to erase them, scientific experiments still sending data back to Earth, discarded equipment, bags of waste. Yes, astronaut poop is on the moon. That's real. The last 3 missions left lunar rovers, actual vehicles, just sitting there in the dust. In total, there are 250 tons of human-made objects on the lunar surface, and about 20% of that came from the Apollo missions. Think about that. We left 50 tons of humanity on another world. Now here's the thing. One side of the moon always faces Earth. It's called tidal locking. The same face forever pointed at us. And NASA chose that side for all the landings so they could maintain radio contact, which means all 6 Apollo landing sites are always visible, always there. Apollo 11, where Armstrong and Aldrin first stepped out, Apollo 12, Apollo 14, Apollo 15, 16, and 17, all of them permanently on display. So naturally, you'd think, let's point a telescope at them. Let's see the flag. Let's see the footprints. Let's see proof with our own eyes. And that's where things get really interesting. The moon is 240,000 miles away. When you look up at it, it only takes up half a degree of the sky. That's tiny. You can cover it with your thumb at arm's length. To even see this much detail, you need serious zoom. Here's the United States for scale on the moon. If we were standing on the moon, looking back at Earth with the same equipment, we'd only get this close. The distances are staggering. Let's zoom into the Sea of Tranquility. That's the dark, smooth area where Apollo 11 landed. It's not actually a sea, it's a plain of solidified volcanic lava. Astronomers in the 1600s thought it was water, and the name stuck. Here's Texas for scale. And already at this zoom level, you start seeing a problem. The image gets wobbly. That's our atmosphere. Variations in air density cause light to refract and ripple. The more you zoom, the worse it gets. Let's push closer to the southern edge. At this level, things are too distorted to see clearly. Here's Houston for scale. The atmosphere is fighting us. Now, experienced astrophotographers have a trick. They record hundreds or thousands of video frames and stack them together. This averages out the atmospheric distortion. I did this myself, blending about 1,000 images over 3 perfect nights. The result reveals craters as small as a mile across. This is about as good as you can get with hobbyist equipment. If we zoom in more, we can see 3 craters named after the Apollo 11 crew: Aldrin, Collins, and Armstrong. Below Collins crater, there's a feature called the Cat's Paw. And just 3.5 miles east of that formation is where the Eagle touched down. It's right there, lost in atmospheric blur and camera noise, taking up less than a single pixel. But it's there. Let me show you the absolute best amateur image possible. This combines 6 of the finest images from experienced astrophotographers with top-tier equipment, perfect atmospheric conditions, and countless hours of work. This is the peak of what's possible from your backyard. Here's an area of Earth at the same scale, blurred the same way. See that light spot in the top left? That's the Kennecott Copper Mine near Salt Lake City, the largest human-made excavation on Earth, 2.5 miles across. And at this scale, we'd barely see it if it were on the moon. A lunar module is 31 feet across. Do the math. So what if we removed the atmosphere from the equation? What about the Hubble Space Telescope? Hubble orbits above the atmosphere. No distortion, crystal clear optics. Surely Hubble can see it, right? Wrong. When Hubble points at the moon, 1 pixel covers about 560 feet of surface. A lunar module would be 1/18th of a single pixel, less than 1% of 1 pixel's area. It's invisible even to Hubble. To actually resolve a lunar module from Earth's distance, you'd need a mirror at least 300 feet across. That's a telescope 100 times bigger than Hubble. We don't have that. We've never built that. What about modern Earth-based observatories, the cutting-edge ones with adaptive optics that correct for atmospheric distortion in real time? The ones that link multiple telescopes together to simulate a 230-foot mirror. Those can resolve details 430 feet across. That's incredible. That's better than Hubble even with atmosphere in the way. But a lunar module is 31 feet, still invisible. There is no telescope on Earth or orbiting Earth that can see Tranquility Base. None. Zero. Which brings us to the only option left.
The Lunar Reconnaissance Orbiter, launched in 2009. It doesn't orbit Earth, it orbits the moon, just 31 miles above the surface. From that distance, its cameras can photograph an area 1.5 miles across with a resolution of 0.5 foot per pixel. That means the lunar module appears as 20 pixels across, about 400 total pixels of image data. And finally, we can see it. Tranquility Base, the descent stage, the experiments, the footprints, all of it crystal clear. By capturing images at different times of the lunar day as shadows shift, we can create time lapses that reveal even more. Equipment trails, the path Armstrong walked to a crater, everything humanity left behind, frozen in time. So here's the answer to the question, can we see Apollo 11 from Earth? No, not even close. And here's the part that's going to stick with you. The reason we can't see it has nothing to do with technology. It's not because our telescopes aren't good enough. It's because of physics, angular resolution, the tyranny of distance. We're separated from the most important landing site in history by 240,000 miles of cold, deadly, radioactive vacuum, and 62 miles of the very atmosphere that keeps us alive. That atmosphere, the thing protecting us every second of every day, is the same thing blurring our view. It's keeping us alive and keeping us blind at the same time. The evidence that we walked on another world is right there, always facing us, and we will never see it with our own eyes unless we go back. And honestly, that's kind of beautiful. The only way to truly see where we've been is to go there again, which is exactly what we're planning to do in the next few years. There's nothing humanity loves more than an impossible challenge. We crossed 240,000 miles of nothing in a tin can with less computing power than your phone. We did it 9 times, and we're about to do it again. The moon is waiting. Tranquility Base is waiting. And this time, maybe we'll stay. If you made it this far, you're the real one. Hit that like button, subscribe if you haven't, and drop a comment telling me, would you go to the moon if you had the chance? I'll see you in the next one.